Good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. We are about halfway through November right now, and if you've been following along with us, you know November has been a crazy busy month. We started off November with a big series of live events in partnership with CNN and their Call to Earth Day. We hosted a whole Call to Earth week featuring the scientists, explorers, adventurers, and conservationists on the front lines of our changing planet. If you want to go back in time and check out any of those episodes, you can visit our website, exploringbytheseat.com, or you can head over to our YouTube channel and find all the events there. This month, we've also have a brand new theme going. This is the first month we've pulled together a collection of events around archaeology, paleontology, and geology. We really want to dig into our planet's past and look towards the future as well. So we've had a lot of really cool events. A new newsletter would have hit your inboxes on Sunday night, so you can see all of those events we still have to come. Today, though, we're going to connect with one of our favorite people to connect with here at Exploring by the Seat of Your Pants, Mr. George Kourounis. He's probably right up there for one of the scientists, explorers who's joined us the most here on Exploring by the Seat of Your Pants. So if you don't know George is a renowned global adventurer, storm chaser, explorer, and television presenter. He hosted several series of a television show called Angry Planet, where he brought the power of our Earth live into living rooms. He's based in Toronto, and his efforts to document nature's worst weather conditions have taken him all over the globe into the normal, the places where normal people are usually running in the other direction. So it could be chasing tornadoes, getting in the middle of blizzards and hurricanes, lowering himself into volcanoes. George is really passionate about the power of our planet, but also bringing it to students and the general public. So I'm going to bring George here live with us right now. Hey, George, how you doing?
Joe, I'm doing great. How are you?
Excellent. George, it's always great to have you joining us live.
I figured it out. I believe it's number 20 of these that I've done. It's at least 20. It could be more. It's 20 that I've been able to count that I have notes on.
All right. Well, there's one constant with your events is it's always jam-packed with students. I can see we've got a huge group tuning in on YouTube right now, so don't be shy to use the chat sidebar. Let us know where you're tuning in from. And then, of course, send us in your questions. I've got grade 5s in Edmonton saying hey, a group in Wisconsin, a group in Florida, Tucson, Arizona, Salt Lake City, Utah, nice. Ontario, who just said hi now. Second graders from somewhere. I'm sure they'll tell us soon. Thunder Bay, there's where they're from. So yeah, we have lots of students with us. We have students backstage. So let's just get into it, George. I'm going to let you take over for a little bit, and then we'll play some Kahoot, and then we'll just let the questions go crazy.
Awesome. Thanks so much, Joe. Appreciate it. I've got a lot of stuff to talk about today, so I should probably dig right in. Today's topic is, well, let me pull up my screen here. Here we go. So today, there we go. We're going to be talking about some of the dangerous things on planet Earth. We live on this sphere. George,
I just want to pause you for a sec.
Yep.
The presentation didn't come to the front on our end. We still see the StreamYard screen.
Stand by. Let me figure this out. should be able to go here.
All right, I see it loading now. It's on the screen.
Whoops. Hey.
And I think if you just click the PowerPoint again at the bottom, it should come up to the front. Yes, we're good.
We're good? Okay, awesome. So there's a few things I want to talk about today, and they all involve different types of natural phenomenon, very dangerous natural phenomenon, that are all sort of linked to the way that the Earth is constructed. So we're going to talk a bit about earthquakes, tsunamis that are caused by earthquakes. We're going to talk a bit about volcanoes and avalanches. So let's dig right in. So as Joe mentioned, I travel around the world all over to try and document these things. I work with scientists, I work with TV shows, and travel all over the world. And all 8 billion of us live on just that thin surface, the crust of planet Earth. And the planet is kind of like, think of it like an onion. There are different layers, and the outer crust is where we live, very thin in relation to the size of the Earth. And then under that is the mantle, and that's hot, sticky rock that the crust is floating on. And then the outer core and inner core, the middle parts of the Earth, are mostly metal, iron, nickel, things like that, liquid, and then solid in the very center, and very, very hot. So the center of the Earth is about as hot as the surface of the sun. And I know that's crazy. It's hard to believe that, but it's true. So we're sitting on this cool outer crust of an extremely powerful heat engine inside the middle of our Earth. And if you were to take the Earth and shrink it down to the size of an apple, that crust that we live on would be about as thick as the skin on that apple. And I find that really amazing because the Earth it's huge, right? And we just live on this really thin crust. But the crust isn't all one piece. It's kind of like a jigsaw puzzle. The surface of the Earth is broken up into all of these different pieces, these puzzle pieces. And we call those pieces tectonic plates. And here in this diagram, it's all one big puzzle piece. And they all fit together, but they're floating on that mantle, that hot, sticky rock that's deep underground. So all of these plates, these tectonic plates, they kind of move, not very fast, but they move about as fast as your fingernails grow. So maybe a few millimeters a year. So they're moving very slowly, but over millions of years, they can move tremendous distances. And these plates, they bump into each other and they scrape up against each other all the time, kind of like ice that's forming in the wintertime on a lake. You've got all these chunks of ice, and then they float on the water and they bump into each other. And when they bump into each other, you get these little pieces that come shooting up. And those are mountains. That's how most of the mountains on planet Earth are formed, by these different pieces of the Earth's crust bashing into each other, and they've got nowhere to go but up. Now, when they do rub up against each other, usually, like I said, it's very, very slow, but sometimes the plates will stick to each other and a lot of energy builds up, kind of like stretching an elastic band. And then you let go of that elastic band and that energy now goes very quickly in one direction. And those are earthquakes. So when these different plates, these tectonic plates, rub up against each other and stick and slide and sometimes they go underneath each other, things like that. But when they jolt and move quickly, we call that an earthquake. And this is a map that shows us where most of the earthquakes happen on planet Earth. And it just so happens that this map is pretty much the same as the map of our tectonic plates, those puzzle pieces. So we know that the places on Earth that are most prone to these earthquakes are the places where those plates come together. And the strongest earthquakes are the ones in black, in places like Japan and Indonesia and up in Alaska. Those are the really, really powerful ones. And the spot where these plates rub together, they're fault lines, we call them. And when they move quickly and cause an earthquake, The exact spot on the surface of the Earth where that happens is called the epicenter. So people might say, oh, the epicenter was here or it was there. That's like the location of the earthquake. But the shaking that is caused by that can spread out over hundreds of kilometers, hundreds of miles. That can be felt quite a ways away. And the shallower the earthquake, the closer it is to the surface where we are, the stronger we're going to feel it. And so we have a scale we use for measuring how strong the shaking is in an earthquake. And if it's down at like magnitude 1, you can't even feel that. If you get up to magnitude 3, up to 4, now all the objects on your desk are rattling around and shaking for maybe 10 seconds. You get up into the strong earthquakes, 5s and 6s, now furniture is falling over, buildings are starting to shake. And when you get into the major earthquakes or the great earthquakes, then entire buildings can collapse and cause widespread destruction across entire cities. But those are very rare, thankfully. And just so you know, if you go from a 1 to a 2 is 10 times stronger than a 1. And a 3 is 10 times stronger than a 2. And a 4 is 10 times stronger than a 3. So as you go higher up in the scale, you have a lot more energy and a lot more shaking. And it can cause cracks to form in the road because, of course, all of this shaking is very violent. Entire buildings can come down, things like that. Now, one of the most interesting phenomena that happens with an earthquake is if you have an earthquake underwater, because that's a thing that can happen. And there's this really cool video I found showing a bunch of scuba divers experiencing, I believe it's a magnitude 7 earthquake underwater. And you can really see the ground get stirred up here. And see the divers are getting pushed around. These guys are wondering what is going on. They're just enjoying their scuba dive and suddenly the entire ocean is shaking. And whenever you have an ocean shaking like that, that water is getting sloshed around. Kind of like dropping a brick into a bathtub, right? And that can cause a tsunami. So a tsunami is a disaster that's caused by another disaster. So there's 4 main ways that tsunamis can be generated. And tsunami is nothing more than a gigantic wave that is caused by something else. They can be caused by earthquakes. They can be caused by undersea volcanoes erupting. They can be caused by landslides happening underwater, big chunks of land sliding down into the sea. Or they can be caused by a meteorite impact. A lot of the dinosaurs that were killed out 66 million years ago were killed by the tsunami that was caused by the meteor that hit in Mexico. So all of these forces move that water, and that water has to go somewhere, and so it sometimes will go up onto shore. It can be very damaging. And probably the most damaging tsunami in recent history happened in 2004. And it was a gigantic earthquake, magnitude 9.3, absolutely huge earthquake that happened off of the coast of Indonesia in the Indian Ocean. And what we're seeing here is how far those waves traveled. So the ground shook for several minutes, very violently. That displaced and shoved all this water around, and those waves crossed the entire Indian Ocean. It hit places like Thailand and Sri Lanka and made it all the way across the ocean to Africa. So there were people that were experiencing these gigantic waves in Africa, not knowing that they were caused by an earthquake thousands of kilometers away in Indonesia. And here's what that looked like in Indonesia. So this video was taken a couple of miles or a couple of kilometers, about 2 miles inland, about 3 or 4 kilometers away from the sea. And the waves, that ocean waves now from the tsunami, are pushing into the city and bringing all of this debris with it. So this city has just experienced a tremendous earthquake. So a lot of the buildings were damaged. And then the tsunami came in, and the water pushed all of those broken buildings and cars and things into the city. And you can see these people getting up away from the water. They're trying to get to higher ground, to try and get up and away from all of this water and debris that's basically sweeping through the city. So this gives you an idea of how suddenly and how destructive these tsunamis can be. So if you ever find yourself in an area near the ocean and you feel an earthquake, if you feel the ground shaking, get away from the ocean. Go to the top of a hill. Go to the top of a building. Try to get as far away from the ocean as possible, because that ocean could come surging in very, very quickly and cause a damaging tsunami. So we mentioned that earthquakes could cause tsunamis, but volcanoes can as well. And interestingly, here's a map of where all of the Earth's volcanoes typically are. And guess what? They're right along the edges of those tectonic plates that we talked about, those pieces of crust that are floating on that mantle, that magma underneath. And there's about 1,500 active volcanoes on planet Earth. And at any given time, you can get between 50 to 70 of them erupting every single year. So our Earth is a very dynamic place. It's always constantly changing. There's a lot going on. And most of those volcanoes happen around the Pacific Ocean in something we call the Ring of Fire. So that includes New Zealand, Papua New Guinea, Japan, parts of Russia, Alaska, and the west coasts of North and South America. And that's where a lot of the world's volcanoes are. And volcanoes, I'd spend a lot of time traveling to volcanoes and documenting them, and I'm going to show one in detail in a minute here. But they can take on different types of shapes. Sometimes they have these very steep-sided slopes, basically a very tall mountain, and sometimes they explode violently. Sometimes they're very low and broad, kind of like the volcanoes that they have in Hawaii. This one here is Mount Semeru in Indonesia, and I photographed this one the day after I climbed to the summit. It took 2 days to climb to the summit here. And while we were at the top, it was exploding with these gray clouds of volcanic ash every few minutes. And so it was a very difficult climb. And we didn't want to stay too long at the summit because it was a dangerous place, obviously. But other volcanoes, like the ones in Hawaii, the lava there doesn't really explode. It flows more like water. And so I took this photo from a helicopter over top of the volcano, where they have these rivers of lava that can travel over land. But one of my favorite types of volcanoes to visit are the ones that have lakes of lava. So you can have lakes that are filled with water. Almost all of the lakes on planet Earth are filled with water, but some of them, there's about 6, have lakes of liquid rock. So it's so hot that inside this volcano, that the rock remains liquid, and it can be up to about 1,500 degrees. And this particular one is in Africa. It's called Nyiragongo. Nyiragongo. It's a tricky one to pronounce, but it's an absolutely beautiful place. And I'm going to show you what it's like to go down inside this volcano. So it's in the central part of Africa, in the Democratic Republic of Congo, and very difficult to get to. It's not many people go here at all. And here I've got a video to show you what it's like to climb down inside and stand right next to this lake of lava. So we've got this drone showing our base camp. And there down in the middle, inside the crater, very, very deep crater, is this boiling liquid rock, this lava. And here I am, slipping. And
Hey, George.
Yeah.
I just want to pause you for a sec. When you switch to the video, I don't think it's switched for us.
Oh, you're not seeing a video?
No.
Clearly very unstable.
Can you hear it?
We hear it, but
what are you seeing?
the screen didn't switch for us. Do you want to try and maybe just reload the presentation and see if that kicks the video in for us?
I can try. Hold on, let me just try one thing here. You see
Yeah.
anything there?
No, it's almost like the share screen just froze on us.
Okay.
Your sound is still very present though, and we could definitely hear you in the video.
Let's see if we can figure this out.
We're definitely having a technology adventure or two today.
So I'm going to stop the share screen. Let's try re-engaging the share screen. Presentation.
Okay.
Can you see the map of Africa?
There we go. We got it.
Okay, now hold on. You can see the map of Africa still?
Yep.
Okay, I'm going to try and play the video. You let me know if it's working.
Okay. We got it this time.
It's back?
Yeah.
Awesome. Cool. So I spent about a week camped at the summit of this volcano. And in the center is this 100-meter wide, about the size of a football field, lake of lava.
Right.
And there I am attempting to rappel down inside, having some difficulty. It took several hours.
It is clearly very unstable. There are huge gaps and cracks and crevices everywhere. So, gotta really be careful where I step. See from the bottom. Okay. Careful. I made it to the bottom, finished the last pitch of the rappel, slipped on the heat suit, and time to go take a walk.
Yeah, sorry, George.
Yep.
It froze up on us as you're kind of making your way down the volcano. I just think whatever's going on with the tech side of things, the speeds are slow or something.
That's okay. No worries, Joe. No worries. Can you... Let me just go here. Stand by.
Yeah.
And I will... Sometimes it happens.
It's not unusual.
So what I'll do is I will not bother with that particular... Might be just that video clip is doing something. I don't know.
Okay.
What I'll do is just go to the next slide. I've got a couple of other video clips, so we'll see how well those perform. But basically, there's this... I was able to walk right up to the edge of this lake of lava in Africa, and it's basically like a window into the center of the Earth. And coming out of that lava is a lot of gas. So what happens is these tectonic plates crash into each other. The rock melts. Inside that rock is a lot of gas. That gas wants to expand and come out. And when it does come out, that's what causes a volcano to erupt. Kind of like putting a Diet Coke with some Mentos. It's the exact same thing. And here's another video clip. Hopefully this will work. And this shows a volcano in the South Pacific erupting more explosively. So here, this volcano has a lot of gas trapped in its lava. And that is me on the right. And here comes a really big explosion. So every one of those chunks is a piece of lava flying hundreds of meters through the air. So these types of volcanoes are much more dangerous than the ones that sort of ooze the lava out slowly. But there's one last thing I want to talk about before we go take some questions, and that is avalanches. Remember earlier I mentioned that when you have these plates crashing into each other, they can form mountains, right? Like the Himalayas or the Rocky Mountains or the Andes. Well, when you get a lot of snow on those mountains, sometimes that snow comes violently sliding down the mountainside, and we call that an avalanche. And part of the reason that happens, of course, there's gravity. You've got a steep slope. Things want to roll downhill. But if you have these different layers of snow, let's say you get a bunch of snow, and then you get some frost, and then you get more snow on top of that frost, then it creates sort of an instability in that snow and makes it want to crack and then slide down the mountain. And if you're in the path of that, it can be very, very dangerous. So a lot of skiers are very conscious of these avalanches, and sometimes you'll see them actually crack, and entire slabs of snow will come shooting down the side of the mountain. Now, of course, these can be very dangerous, especially if there's a highway at the bottom of this mountain. That snow could slide down and knock cars off of the highway.
Sorry,
So
George.
what happens sometimes, and
I'm going to derail you one more time.
Yeah.
The video did play. We saw the big explosion, which was awesome, but it didn't transition from the video.
Okay. Unfortunately, we're having some technical difficulties today.
That's okay. We've been able to fix it each time.
It's all good.
All right, I see snow.
Okay, hopefully this video plays. So it can be very dangerous when snow slides down the side of a mountain and hits things like cars. So what happens quite frequently, I live in Canada, and we do this in Canada frequently, is sometimes the authorities will shut down the highway, use explosives to trigger that snow, to give it a bump, if you will, intentionally bring the snow down onto the road with the road closed, then they'll plow the highway and then reopen the road. So I've got a video here, and I really hope this plays because it's a cool video of a man-made avalanche that I filmed, and I'm literally hanging outside of the window of a car as we're filming this avalanche, and I hope this plays. So here, the snow is starting. I apologize for it being a bit shaky. Here's the snow rushing down the side of the mountain, and I'm with the patrol here, and watch the snow explode through the trees. And it got a lot closer to us than we were expecting, and we got dusted by that avalanche. And one of the things I wanted to do was to try and put a camera directly in the path of an avalanche to show what it looks like if you were to get hit by that snow. And so I did that, and I hope this video works. Oops.
It looks like it's not transitioning, George. I think for some reason when you play a video, it just freezes everything up. The video played. We saw it come down, but I think for whatever reason, after each video, it just kind of doesn't want to go any further.
Interesting. Okay. So this should show the camera getting hit by an avalanche.
There goes the camera.
And that's how quickly it can happen. I've got... You know what, Joe?
Yeah.
Let's just go to questions.
Okay. I like that.
Let's just go to questions, because I think that's easier. And I'm sure there's a bunch of questions out there.
No question. There's already tons of them in the chat, so I'm going to have to race through some of those questions. We're going to get through as many as we can. So I want to visit our camera classrooms, and in between, visit some of our YouTube classrooms. So we've got you back. Sorry the tech didn't cooperate for you today, George, but we made our way through. We still got to see most of the videos.
The important things, get some
All right. So St. John's Lutheran, I've got some fifth graders with me. How's everyone doing today? Hey, everyone. I'm wondering if we have a question or two for George.
Go ahead, Connor.
My question is, how many
Can we get that a little bit louder?
A little louder, Connor.
tectonic plates?
Did you get
Yes.
that, George? How many tectonic plates are there?
Geez. You ask a really great question. I should know that number off the top of my head, but I don't. I'm embarrassed to say that I don't know the exact number. It's somewhere, it's about 20 or so. That's an easily Googleable question. I apologize for not knowing that. I should know that. Some of them are pretty small, so it's hard to say, like, define which is a plate and which isn't. So there can be some debate as to how many there are.
Yeah, I see 7 major ones. But I don't see a consistent or like consensus on how many actual ones there are.
Yeah, there's a bit of debate, actually.
Yeah. Yeah, I've got estimates of 15 to 20, but I think you're right, George. I think people are still trying to decide.
Yeah.
Okay, 5th graders, you got another question there for us?
Yeah. Why does it take so long for tectonic plates to move?
Why does it take so long for tectonic plates to move? Great question. So what happens is, deep inside the Earth, there's all this this hot, sticky rock, and there are the heat wants to rise, right? If you put your hand over a candle, you can feel that heat that wants to rise up. Same thing happens inside the Earth. So that heat, remember, the inside of the Earth is as hot as the surface of the sun. So that heat wants to come up, and when it hits those layers of the crust, that heat comes up and spreads and moves, and it pushes those plates, nudging them ever so slightly. So inside the in the oceans, in the middle of the ocean, we have a mid-Atlantic ridge. That's where the plates are separating. So you have that mantle plume coming up, pushing the plates apart. But the force of that is only strong enough to move the plates ever so slightly. And I'm very glad for that, because if the plates moved really quickly, then we'd have a lot more earthquakes, and Earth would be a much more dangerous place to live. I'm glad they move slowly.
All right. Thanks, 5th graders. We're going to come back your way shortly. I'm going to go to the Keller crew this time. We got the Keller crew hanging out with us. I believe they are hanging in Kansas. How are we doing, Keller crew?
Go ahead.
I love Kansas.
What inspired you to do this cool job?
What inspired me? Well, when I was your age, I was very interested in science and nature. I wanted to be a marine biologist at the time, but I ended up taking a different path. But I always had that curiosity about planet Earth, about all of the forces that shape our planet. And as I got older, I started to investigate those on my own by chasing storms and tracking tornadoes and visiting volcanoes and things like that. And I was able to slowly make a career out of it. But it was always that passion, that interest in and fascination with science and nature.
All right. We have another one there. I bet you George has been around your area chasing tornadoes at some stage.
I've been everywhere in Kansas, pretty much.
Whenever you're right next to like a tornado or avalanche, are you ever like nervous, or are you just always just excited about it?
Am I ever nervous, or am I just excited? Great question. Yes, I get nervous, absolutely, because I get up close to these things that are very dangerous. So I have to try and do it as safely as possible. And to do that, yeah, it is scary. If I wasn't at least a little bit afraid, then I might go too far and put myself in danger. But that little bit of fear that I have, that respect for Mother Nature, that informs me to, hey, George, maybe don't get so close. Maybe take a few steps back, or maybe not, don't push your luck. So yeah, it is exciting for me. I love it. I'm excited about documenting these things and sharing what I see, especially with classrooms like this. But of course, yeah, I get afraid. I'm a person, just like everybody else.
All right, Keller crew, we'll try and come back your way shortly. I want to dip into our YouTube question pool because it's getting kind of big, so we got to get a few of these out here. Let's see. Elise wants to know, George, do you have a favorite force of nature or natural disaster?
Do I have a favorite? So I've documented pretty much everything in terms of all the different types of forces of nature and natural disasters. I really do like volcanoes because they are the one force of nature that creates as they destroy. most natural disasters are these forces of destruction, a hurricane, a tornado. But volcanoes can create new islands, and they can create new mountains, and they are responsible for most of the crust that we live on. We owe our existence, our lives, to the fact that there have been volcanoes for millions of years. They planted the seeds in our atmosphere that we breathe back in the day, millions of years ago. So I find them particularly fascinating.
All right. Anna is curious. You told us how hot the core is. What if our crust became cold? Or not our crust, our core became cold. What do you think would happen?
Wow, that's theoretical, isn't it? If the core became cold, well, a few things for sure. That motion that causes the tectonic plates to move would stop. It's that internal heat that causes that. So there would be no more volcanoes. There would be no more earthquakes, because all of the tectonic plates would basically freeze and lock into position, and they'd stop moving. Great question. I never really thought about that.
All right. One more, and we'll go back to some camera classrooms. This is from Yuna. Yuna wants to know, how long can volcanoes stay dormant before they erupt?
Fantastic. Sometimes hundreds of years. You could have a volcano. There was one in Russia not too long ago that sat dormant for 700 years. And then one day decided, you know what? I'm going to erupt today. And it did. So you just never know. These volcanoes can sit with the pressure slowly building up of these expanding gases inside the magma. Slowly, 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 the pressure builds up to the point where at some point the pressure inside is greater than the force that's holding it in, and eventually, kaboom. So it could be tens of years, hundreds of years. There are volcanoes that have been sitting for thousands of years.
All right, we're going to Burlington, Ontario, some grade 5, 6s hanging out in an audio spot. How are we doing, grade 5, 6s?
Good.
Yay!
All right, let's grab a couple questions.
How does the lava protective suits work?
How does the lava protecting suit work? I wish I had it here. It's down in my basement. So the way it works is there's a lot of heat that comes off of that lava. And the suit is made from a special fabric that's covered in aluminum. And it's very shiny, right? Kind of like aluminum foil. And because it's shiny, it reflects a lot of that heat back out. And so it protects me from getting burned. But the problem is that it's very bulky and heavy. So if you've ever worn a snowsuit in the summertime, you understand that you're going to get hot really quick because your body heat inside that snowsuit is going to build up, right? That's why we don't wear snowsuits in the summertime. Well, the same thing happens with that. Yes, I don't get burned from the lava, but I get hot very, very quickly, so I can't wear it for too long.
All right, you have another one there for us, Tom Thompson crew?
Yes, we do.
Excellent.
What's the biggest, most recent meteorite that hit the Earth?
The biggest, most recent meteorite, there's a very famous one that hit a few years ago in Russia at a place called Chelyabinsk. And go onto YouTube and look for Russian meteor. And you'll see a whole bunch of YouTube videos. This meteor entered the Earth's atmosphere over a remote part of Russia, and it exploded in the sky. It didn't actually hit the ground, but it created such a shock wave. The explosion was so big that it shattered windows for miles and miles around. It created this massive explosion. And the videos of it are really, really cool. I highly recommend checking it out.
All right, we'll swing back to some camera classroom shortly, but I've got a pile up of questions here on YouTube. So Lauren wants to know, is there an earthquake level that's more common? We talked about the scale. Is there kind of, do we see them fall in kind of a common area?
Yeah, so basically the lower the magnitude, the more common they are, right? So the tiny little earthquakes are so common that in some places, some parts of Japan, they happen pretty much every day. And you don't even notice them. The higher up you go on the scale, the more rare they become, and that's a good thing. So yeah, so it's pretty simple. The smaller earthquakes are much more common. The great earthquakes, as we call them, are thankfully very rare.
All right. Got a question from someone in Florida, and they want to know, George, when you're getting ready for an expedition, what kind of medications do you have to take?
What kind of medications do I have to take? Well, it sort of depends on where I'm going. If I'm going to be on a ship, I'll bring my seasick medication. If I'm going to a place that has a lot of mosquitoes in the tropics, I'll bring my malaria medication because I don't want to catch malaria from a mosquito. I have all kinds of vaccinations for different parts of the world because you need certain vaccinations to go to different parts of the world in Asia and Africa, things like typhus and Japanese encephalitis. So I've got a list this long of all the vaccinations that I've had, and I try to protect myself because there's nothing worse than being sick when you're out on an extreme expedition. One other medication I bring, Imodium, because if you've ever had diarrhea, I know it's awful. Believe me, it's 10 times worse when you're living in a tent on top of a volcano.
All right. Your stomach's just not used to some of that new food. Okay, one more from YouTube before we go to our camera crew. Brianna would like to know, George, what's the largest tsunami that you've heard of?
The largest tsunami that I've heard of? Wow. So there's that question could fall in a couple of different categories. There was one that was in Alaska back in the I can't remember what year it was. Middle 20th century, I want to say, where there was a gigantic landslide that plunged into a bay, and the water went up the other side of the bay, and it went over 1,000 feet up the mountainside on the other side. Absolutely huge. The tsunami that was formed by the meteor that wiped out the dinosaurs would have gone. It would have been massive. It would have gone. I'm looking at a map of the world right now, and that tsunami would have reached well into the United States, probably into, let's just say all of Florida was probably underwater. Absolutely massive.
All right. Let's get some faces in here. Let's go back to our 5th graders. See if they have another question or two for us.
How do you know a volcano won't erupt when you are inside it?
Have I ever had a volcano erupt while I was inside it?
I think they're wondering, how do you know it's not going to before you go in?
So, I spent a lot of time studying these volcanoes and the type of activity that there is at these volcanoes. So the ones that have the lakes of lava, they tend to not explode very often. Very, very rare, although it does happen. So those are the ones where I can get inside and get very close to the lava. You go there for a short amount of time and then you leave. Some volcanoes, they have a tendency to explode more often. Those ones I sort of avoid and don't go too far inside. Now, there have been instances where I have been inside a volcano, inside a crater, and it has exploded. And there was this one instance where I had to look up in the air and watch the pieces of lava flying through the air, and I had some of them landing behind me. And that was very scary, and so I got out of there as quickly as I could. So the trick is to study the volcano, know what it is typically going to do, and then limit your amount of time in there because you just never know.
All right. What do you think, 5th graders? You have one more for us?
What is the scariest thing you ever did?
A little louder, friend.
What is the scariest thing you ever did?
Scariest thing you've done, George? What had you shaken the most, or maybe the most nervous?
What has made me the most nervous? Ooh, wow. That's a great question. The hours lead. I do a lot of chasing of storms as well, and the hours leading up to Hurricane Katrina was terrifying because we knew how bad this storm was going to be, and we were in a place where we knew it was going to be very, very bad, and it was. The storm itself wasn't so scary. It was that anticipation, knowing that the storm is coming. That was pretty scary. Yeah.
All right. 5th graders, thanks for all those great questions.
Thank you.
we're gonna jump back to the U.S. and back to Kansas. I saw a ton of hands before, so I think they probably have a question or two sorted for us.
What kind of training do you have to go through to be able to be a storm hunter?
Right. So it helps if you understand meteorology. I'm not a meteorologist, but I've learned enough that I am able to forecast the weather and be able to forecast where I think a tornado might form or which direction a hurricane is going to move in. I've spent a lot of time studying things like how to use ropes and climbing and first aid and geology and volcanology and all of these different things in order to try to do what I do as safely as possible. And that is the most important thing, is the more you understand and the more study, the safer you will be. There's lots of careers out there, volcanologists and meteorologists and researchers out there that I work with, and I sort of specialize in going that extra little distance to get some of the samples or to get the video or get the photos or whatever from places that are just a little too difficult or too dangerous for most of those guys to get themselves. And so, yeah, it all comes down to just studying as much as I can about pretty much everything. A lot of reading.
Cool.
All right, let's grab another one. Here comes someone.
What has your favorite adventure been?
My
What
favorite
has your-
adventure film?
No, just your favorite adventure that you've been on.
Oh, my favorite adventure that I've been on. Well, there's been a lot of them. My favorite one, I think, was one that I did in Turkmenistan. Joe knows this one very well. I was working with National Geographic, and there's a pit of fire that's been burning for 60 years. It's burning natural gas. And I became the first person ever to go down inside, spend a short amount of time at the bottom gathering samples, looking for any type of bacteria or little microbes that might be living in this really hot crater filled with fire, thousands of fires, totally surrounded by fire. And we found some in there. And that can give us clues as to where we might want to look for life on other planets. And so it was a very difficult expedition. It was dangerous. It was very dramatic. And there we've got some photos. Joe's brought up some photos. There I am.
Pictures here from that one.
Gaza. And I got a Guinness World Record for being the first person to ever venture to the bottom of this place. I did a whole Exploring by the Seat of Your Pants talk about this place. So if you look on the archive, you should be able to find it.
All right. There's a few pictures. In fact, George, if I type your name in on Google, this is the first thing that comes up.
That does not surprise me.
And it used to be, I don't know if it's still there, but there used to be a picture of it as well on Nat Geo headquarters.
Well, they're renovating the headquarters, so it's likely down. But I hope it's in the basement somewhere. I'd love to get that up, take it from them.
All right. Thanks to our Kansas crew. Those were some great questions. Thanks, everyone. Tom Thompson, if you'd like to go ahead, we'll get another couple from you, and then we might
Yes,
be there.
we have two more.
What's the longest you've ever been in a volcano for?
The longest I've ever been in a volcano?
Yes.
I have spent 5 weeks camped on top of an active volcano in the South Pacific. And then dropping down inside that volcano, I would have spent quite a few hours, maybe 5 hours inside. And I've been to the bottom of that volcano now on 5 or 6 expeditions, 11 descents to the bottom. So I've spent a good chunk of my life inside volcanoes. And that's just that one volcano. I've done this in Ethiopia and Congo and Guatemala and Vanuatu and all of these different places as well. But spending 5 weeks living on top of an active volcano, living in a tent in acid rain was challenging.
If you could go into the past and explore or investigate a natural disaster, which natural disaster would it be?
Awesome question. I love that. If I could go back in time, what I would love to see, I would love to be on the International Space Station looking down on the day that meteor hit 66 million years ago that made the dinosaurs go extinct. to see that from above and to see the effects, the global effects of that one tiny little rock. The rock that did that, the meteor, was about the size of the city of New York. So it's not that big compared to the size of Earth. So to be able to witness that and to see how that affected our entire planet, would be fascinating to see. I would love to check that out. Someone please build a time machine that I can put on the International Space Station.
All right. That was a really cool question. That's a pretty good choice. It doesn't get much more powerful than that. Pretty impressive.
Yeah, well, it does, and that's what's scary. There are space rocks out there that are much, much bigger. Our moon was formed when another gigantic space rock hit Earth, and the two of them hit with such force that enough debris from planet Earth and that other rock went up into space and formed our moon. I mean, that would have been, I would love to see that too.
All right. George, I'm going to take one more from YouTube. Where did it go? Oh, okay. This is from Air. This is Ari. Ari would like to know, you talked about the layers of the planet. That's not something easy for us to see. So do you know anything about how scientists were able to figure out what makes up the layers?
The deepest hole that we have ever dug, it's called the Kola borehole. It's in Russia. And they were only able to just scratch the surface of our crust. It's so difficult and gets so hot down there that we can't drill that deep. So we've never actually seen the interior of the Earth. But when there are earthquakes, we can detect those waves, those seismic waves, the shaking of the Earth, and we can detect how those waves travel through the Earth. And by having seismometers around the world, we can get a pretty good idea of those layers inside the Earth. So we're getting basically indirect measurements. We can't drill down and sort of measure the Earth's core, but we've got a pretty good idea from measuring these seismic waves of how big the core is, what it's made of, how dense it is. So even though we've got a pretty good idea, there's still a lot we have to learn.
Okay, perfect. George, something that came up a lot in the chat is people are impressed with your patience for when your tech wasn't cooperating. They thought that you were awesome and you stayed so cool and collected during that. But I think that probably comes with expeditions around the world.
And I used to be an engineer. I used to build and maintain recording studios for a living. So a lot of what I used to do is troubleshooting under pressure. And so the trick is when things go wrong, there's no point in getting flustered. This is not a life or death situation, right? And I've been in a lot of those. So if you're having problems with your tech, you know what? You roll with the punches, you go to the questions, and it's all good. It's all good. I appreciate everyone's patience because it's you are here to see the things that I want to present to you. So I'm very happy that you're all okay with it.
Well, it's a good lesson for classrooms and especially our future scientists and explorers out there. Flexibility, calm and cool under pressure. These are all really good skills to have when you're out in the field because things don't often go as planned.
They never go as planned.
Yeah.
Never.
Yeah, absolutely. Well, George, I want to start off with a huge shout out to our classrooms. We had a great camera crew today. We had tons of students firing questions at us on YouTube. So a big shout out to all the classrooms who joined us, those who might catch this later as well. It was great to have you with us. George, it's always a great pleasure to steal some of your time. And I think you intrigue students with the Earth is trying to kill you title today, or Earth wants to kill you. We live on a moving, dynamic, changing planet. And it's really cool to have people like yourself out there and bringing these stories to us and capturing that power of our planet.
Awesome. And I just want to plant the seed, Joe, if you don't mind.
Of course.
I think there might be an opportunity to do a live broadcast from Antarctica pretty soon sometime over the next 4 months or so. So we're going to talk about that and maybe bring you some cool stuff live from.
We just might have the technology to help out with that, George. So I will keep my ears and eyes looking for that email. And I want to bring in the camera classrooms who are still with us, because it's always great to get a nice big shout out from our classroom. So here's a few of the groups here. If you guys want to give us a big shout, a big thank you, a big goodbye before we sign off today. Thanks so much for hanging out with us. Thank you to our classroom on YouTube. We're going to sign off for today. Thanks, everyone. All right. Well, George.